Alright, so in last problem here, let's put them all together and start doing all these transformations. So up at the very top right of that note sheet, they're just getting you to recall that when you did this with quadratic functions or absolute value functions, the same rules applied, where that a value indicated the stretch or compression. It also indicated reflection as well. Okay, and then we still have our h and our k. I would still handle these problems exactly the same way that we've done before in the past. And so let's go ahead and do that here on this problem. So if they're asking us on this problem, what is the graph of y equals negative 1/2 times the square root of x minus 3 plus 1? First thing that they did is they made the parent function, which I'm going to possibly skip that step a little bit there, and instead I like going straight to step. um, and I'll probably do this in a little bit of a different order, but I do respect what they're doing there. You get that first step going on there, and then because the function has a vertical compression of 1/2 and also at the same time a reflection, we take those four dots, those three dots right there, of 1 squared being 1 and 2 squared being 4, square root of 4 being 2, I got that backwards, and then reflecting them, but then also cutting that distance in half, and so that's why you see these marks here in red, and then this mark right here in red. Okay. After that, what they did next is then they applied this whole opposite same game here when it comes to the quote unquote, I'm going to call this the vertex, if you will. Remember, a full parabola would have a vertex right there, but really we have just half of a parabola. But I'm still going to use some air quotes here. I know you can totally see me moving my two fingers on both hands for my air quotes, but we're really moving this thing here 3 units to the right and 1 unit up, and that's why you see that graph right here in blue. And then we still have the whole 1 to the right and then down a half, and then reset back to that starting point right here, and then count 1, 2, 3, 4, but then they only go down 1. Okay, so there's the correct answer of that graph would be this one here in blue. That's your final step right there. I'm kind of going to do this in a little bit of a different order here, and and you might think this might be more complicated. Personally, I take their 3 steps and I just do it in 2 steps. Okay. The reason why I do this in 2 steps is just because personally, when it came to graphing parabolas, the very first thing I worried about with parabola graphing is where was my vertex, and so that's essentially what I worry about here with this graph here. So take a couple seconds, talk to the person next to you. Can you figure out where our quote unquote vertex or our starting dot would be on this graph? And here's your hint. It would have to do with these numbers right there. Okay, so where would our starting point be with those two values there? You got it, right? Our vertex, aka our starting point, should be at -2 and then -4. So I'm going to put that spot. Let's see here, right down there. You can barely see it. Let me scroll down here just a little bit. And there you go. Then, here's what else I want you to notice here also. I'm going to make this the parent function here. And if this really was this graph here, because we still have that multiplication of 3, I'm not going to multiply by 3. Instead, I'm just going to treat this like, hey, if this was just moving this graph just 2 to the left and 4 down, I'd have another spot right there because the square root of 1 would be 1, and then the square root of 4 would be 2. So you notice I'm just counting squares, 1, 2, 3, 4, and then I can go up 2 units. So right there would be the graph of that function. Okay, now here comes step 2. Step 2 now requires us to look at the fact that that a value right there is 3. What we're going to do now with those 3 dots that we just put here is we're just going to perform a vertical stretch of each one of those points by a factor of 3. Here's how this can look visually. Picture that distance from, say, that starting point right here to that spot right there. I'm going to use a green highlighter like that right there. See how that just went up a total of 1? So because it's a factor of 3, imagine us taking that 1 and now tripling that distance. 1 times 3 would make us now go 3 up. And then let's do the same thing with the other dot over there. Since that's 2 units up from horizontally where that starting point, that quote-unquote vertex would be, if I were to triple that length, tripling that would put me way up there. Okay, so from there, now I can put in my new dots or my new graph. So of course, I'd still have the same starting point right there as before, but now I'd have another dot right there at the end of that spot. See how that's 3 units up from that starting point, and then 1 to the right. And then if I were to go to the right, the square root of 4 would be 2, but I got to take that 2 and then multiply it by 3, so I got to go up a total of 6 units. Don't look at these numbers along the side. That's a big no-no. Instead, count those squares. And so I should have another point right about there. And then I can curve and put the rest of that square root function in there just like that. And so, sure enough, there is my new function right there of y equals 3 times the square root of x plus 2 and then plus 4. Some old school math teachers will do this to their square root, put that little mark like right there to really make it clear that the square root stops right there, and then the plus 4 has no chance of being underneath that square root. I like it. I wish more students did it, so that way I don't make that mistake of misreading what you write and accidentally putting numbers underneath radicals when they shouldn't be. Okay, so that should help you get through the last lesson of this unit. I'm going to make a completely separate, different playlist for the chapter review. So you'll get that chapter review a couple days before the test. I'll have a whole new video series on that one, as well as a static copy of the review, so you can check your answers with that as well. Okay, so thanks for watching, everybody. Good luck with that homework. Take the time, get that homework done, check your work, please. Once again, please email me. That's mcook2@lakeviewspartans.org. If you have any specific homework questions, I'd be more than happy to send you a little video to help you out with those. No problem. Okay? Happy homeworking.